Okay, for running MaxEnt, normally it takes a fair amount of prep. MaxEnt only supports ASCII grid files, which all standard JS packages, ArcGIS, Bluespray, QGIS, all of them will export rasters as ASCII format. Now, I'll also show you in the next video how to set these up a little bit easier using Bluespray. It'll create the files for you. Then there's a CSV file for the samples. The first column needs to be the species, and then X and Y, and then a folder for outputs. There is a great tutorial, again Steven's tutorial on MaxEnt, which will also explain how to create all these. Alright, so what I tend to do is I create a folder for each modeling exercise, in other words each run that I'm going to do, and then have a subfolder for the layers. Again, they need to be the same extent or number of rows and pixels, columns of pixels, and then the samples in a CSV file. The first column needs to be the species name, but it really doesn't have to be. It can be anything. MaxEnt was created to allow for different, multiple species to be in the same CSV file. Most of us don't use that feature, so you can just put whatever you want to in the species column. And then have a subfolder for each output or each run, and that's really important so that you can save the different runs that you do. Also note, points can be missing environmental data. In other words, your occurrences don't have to completely overlap with your rasters. MaxEnt will give you an error, but that's okay. You can just click and get past it. One of the things that MaxEnt is written in Java, as Bluespray is. If you need to increase the amount of RAM that's available, you can run this batch file, okay, just by double clicking on it. That will run this command line. In other words, it's going to run Java, and then it's going to run the MaxEnt jar file, which is what Java programming code is delivered in. And this interesting parameter actually sets the amount of RAM, where this is 512 megabytes. So if you run out of memory, you can come in and change this and make this a larger number and run it again. If you double click on the jar file, it will also just run, but it'll run with the default memory configuration, which I think is fairly small. Okay, this is the MaxEnt GUI. The key pieces are being able to specify the samples, okay, or your samples.csv file with your occurrences in it, and then your folder with your layers in it. If you browse to it and then click load, it'll go ahead and load up all the layers that are in that folder. You also definitely want to turn on create response curves, pictures of predictions, which is really the habitat suitability model, and do jackknives. Also to go ahead and browse to your output directory. In this case, I've run some Doug fir points against precipitation, I believe, and here's what our AUC curve looks like. Pretty nice, 0.9 AUC value. But if you run it across different ones, you're going to get these kind of response curves. And again, note that this was done at the default, which is where they're more complex than I feel comfortable with. Now, in the MaxEnt output, you're going to get an HTML file similar to Hemi. It's going to have a whole bunch of things. It's going to have the response curves for each predictor. In other words, the partial response, kind of like we saw with the GAM, where here this is the response curve for the DEM, for its component of how much of the model it explains, and then annual precip, mean temp, warmest month, coldest month. So each of these. These are the response curves if only one predictor, one covariate is used. So here's the DEM all by itself, and notice it looks quite a bit different. So in other words, this is a model built just with the DEM. Same for each of these other ones. The surface output, the default is logistic. That's what pretty much everyone uses. You can also get the raw output out, but you probably want to use the logistic, and that's where we're going to be able to smooth it by upping the regularization parameter. And here's a sample output. Again, this would be logistic, but again, we've got our Doug fir habitat pretty well identified. A couple of other things. There's a table here that shows the contribution to the model. So typically the strongest predictors, okay, in this case 82%. And then MaxEnt internally will run a Jackknife, and so down here you can see what happens. The dark blue line is the model with just that predictor being run, so you can see the DEM not really very good, down at 6%. Okay, where precipitation, when you just run it, does really well, better than any of the other predictors. The red is then all of them together, okay, and then the whatever color that is, the cyan or sort of greenish blue line is run when the model is run without that variable or with all the covariates except that one variable. Okay, so here we can see that precipitation is definitely the most important, because not only is it the best model with just that variable, but when you run it without it, it gets the lowest score. Now notice it also actually does better than we might expect with running without it. And all of these, especially warmest temp and coldest, temperature of warmest month and the minimum temperature of coldest month, do pretty well when you remove them. So we probably want to remove one of them, at least, maybe both, and just go with mean temp. Or remove main temp and see what happens to these two. Those would be interesting experiments to run. All right, when you go into the settings dialog, very important to set the regularization multiplier. This is that regularization value. I've upped it into the range of 10, 20 sometimes. That's unusual to see in papers, but I like it because it is simply just too complicated for me to feel comfortable with it. And we get a very high AUC. So as you up the regularization, your AUC is probably going to drop. I'm okay with that a little bit. You don't want to do too much. MaxEnt inherently uses leave one out cross-validation, so it breaks it up in n chunks, similar to what we've seen before with k-fold cross-validation. And then it does that over and over again, but it uses the word replication, just another word for resampling over and over again, or Monte Carlo. To optimize your model, my advice is select the sample area carefully. If you want to get a better AUC value, you can just increase the sample area, but that's not really valid, right? You want to pick the sample area for where is it you're looking. So in other words, if you're modeling an invasive species in the American Southwest, as we did with tamarisk, you'd want to pick the American Southwest, the Southwest area of the United States. If you were looking for all of North America, if you look at just the continental U.S., it's kind of an artificial thing, right? Because we're just a country boundary. So think about that and how your species is going to respond to that. If you're working within a refuge or a national park or something like that, it's pretty easy to just pick the park. But again, with habitat suitability models, they tend to work better over larger extents, and you see more with them and get to include more occurrences to capture a larger area of the environmental variability that a species might live within. The percent contribution within the Jackknife can be used to determine the best predictors, and I recommend not only studying those, but trying different ones. And definitely try different regularization parameters to really get the response curves you're comfortable with, and publish with the response curves. Okay, very important to do that, so we're seeing how complex those are. And then run replication to determine how robust the data is and your model is against your data. So optimization and selection with this is the modeling approach. Or kind of to summarize, now that we're wrapping up this area of the class, which modeling approach you use is critical. The predictor or covariate independent variable, whatever you want to call them, selection is very important. Coefficient estimation is important, and then validating this against subsamples of the data, or best case a new data set. Parameter sensitivity is something else to look at. In other words, like in MaxEnt's case, what would happen if we jiggled the regularization parameter? What would happen if we changed it? That would be interesting to see if there's suddenly changes in the response curves, which we see sometimes. And then just overall uncertainty estimation, being able to estimate how certain are we, and producing hopefully uncertainty maps with that. So to summarize, I've created this little table that shows the trade-offs between the different approaches. Now I left GLMs off because it's pretty much a linear, it's modifying the data, but it's a linear within the linear family, as are general linear models and regular linear models. So I put in GAMs, BRTs, and MaxEnts. For each of these, the number of predictors can be any number. The base equation, what it uses internally, is linear or linearized for linear. GAMs, remember these links and splines. BRT uses trees. MaxEnt uses these different thresholds. So MaxEnt definitely have the most flexibility there. The fitting approach, direct analytic solution with linear. With GAMs, they solve a derivative for the maximum likelihood. In BRT, very complex, makes a tree, add ones. If it's better, it keeps going and keeps adding, merging trees together Sometimes you end up with tens of thousands of branches in your tree. MaxEnt does a very interesting search for the best solution. Highly recommend Stephen's paper if you want to read more about that. The response variable, so linear and GAMS. I think GAMS can have categorical now that we're running them in R, but BRTs definitely can be categorical, or they can be continuous by having lots of branches and effectively simulating a continuous curve. MaxEnt does continuous or categorical. I'm just going to edit that. And the real thing that's driving which one is, of course, the response curves and the nature of it. So linear, we would only use that with continuous, and that the data was linear or we felt could be linearized fairly easily. GAMS, continuous. Oh, sorry. Okay, I'm going to stop there.